Right, hello and welcome. In this example, we are going to look at how to calculate the total reactance with a voltage that has a frequency of 5 kilohertz. Right, so this is an AC waveform that we expect in here, and it's going to connect across here, and it's going to have 5 kilohertz as its output. And so we see from that perspective, we can travel up and hit a parallel branch through L1, another parallel branch through L2, and a third parallel branch through L3. And we see that they all connect all the way down to ground. Right? So they're all fully in parallel. So we'll use that and do our parallel because we need to find our LT so that we can use that in our XL equation. That's what they're asking for. Total reactance in this case, since they're all inductors, it's going to be the XL value. But later when you have inductors, resistors, capacitors all together, you're going to be using ZT, right? The total reactance. So our XL value here is 2 pi FL. They gave us the frequency here, and so we need to find the total inductance to plug into that equation. So we're going to start there. And we just said that it was L1 is in parallel with L2 in parallel with L3. So we'll plug that into our calculator over here so that we have 1 over 1 over L1, which is 1 millihenry. Watch out, we're going to move all of these into millihenries. Let's move those forward using our decimals, actually. So this is a microhenry. We'll knock that off and move it forward by 3. So we'll say that it's 0.45 millihenries, same number. Right, same with this one. We'll move this one forward by 3, and we'll put that as 1.1 millihenries. Right, again, same number there. We just moved them forward using our notation. So that makes it a little bit easier on us. So now we can use or leave out our notation mainly, and we say plus 1 over. Our L2 value is 0.45 plus 1 over our 1.1. Right, now we're getting a small number here, and that's in millihenries. So we can say our total inductance is equal to 0.242 millihenries. And we can plug that in for our XL. So now we can say XL, our total reactance in this circuit here, is equal to 2 pi, our frequency. We know that that was 5,000 hertz, and multiplied by our inductor here of 0.242 millihenries. We'll send this out and plug in. We'll say that we have 2 pi times our 5,000 hertz multiplied by our 0.000242, and that's our milli value there. And so now we're left with an XL equal to 7.6, and that's now in ohms, right? So if we're going to use Ohm's law, if we're going to need to calculate the net reactance or the total reactance, the current, any of that, the voltage drops, we need to make sure we're using XL. Okay, let us know if you have any other questions.